For our wrap up this week, I wanted to do a quick video to explain a couple ideas that are popping up in the discussions to make sure that everybody is clear. Number one is the idea of significance of a model, and what do we mean by the p-value or the significance. The second one is looking at that R-square for how well the model predicts the outcome variable. The third thing that I want to do is provide a short parallel to how we might apply this in OPWL type research. So remember that when we do multiple regression, the outcome variable should be a scale variable. In the case that we used in our textbook, it was math achievement. And so we know that scale, the scores range from, let's say if it's a grade of math achievement, you would have between 0 and 100. If it's an achievement test, obviously your number could be whatever the measure on the achievement test is. I can't remember what it is here. But we've got our outcome variable, dependent variable is the math achievement test. So we can see that right there. So the first thing we're going to look at is the ANOVA table, and this is the test for significance. And you can see here that the significance, or the p-value, is less than 0.05, and SPSS has rounded it down to 0.000, which means it's very significant. Well, what is very significant? The model that we've put together, so the collection of variables that we decided all seem to make sense theoretically to contribute to this math achievement. And so what we're saying is this R square of 0.343, this is the adjusted since we have multiple variables, is this number significantly different than 0? In other words, if we were to look on our normal curve of data, so I'm just going to pull in here a normal curve. I just picked one out of the internet. So if our data that we are looking at in this model with this significance was mapped on a curve, what we're saying by being at 0.000 is it's way out here. The chances of this model, of our model, being significant are way out here. This is anything could happen by chance, right? I mean, so many things happen at the height of the curve. Out here, chances are it is what we say it is, and we can then reject the null hypothesis and say this model does indeed seem to contribute to math achievement. So that would be positive for our research. And then we want to again remember that it is with this combination of variables. Now, another question has been around the meaning of the strength of the model, right? How predictive is it? So 0.343 is saying that 34.3% of math achievement test is explained by grades in high school, father's education, mother's education, and gender. Well, let's just think about that logically. Grades in high school, if you've done really well in high school, chances are you're going to do better in terms of your math achievement test. You're getting ready to go into college. If you've done well, you've got some good cognitive development there around math. Father's achievement and mother's achievement, both are going to come into play. Think about a lot of families where the parents can talk about their education or talk about education, can help their kids in school, in their assignments, things like that. So the more advanced a parent's education is, chances are the more advanced the kid is going to be able to be. That's just out of social science research. Gender also, we know from social science research, comes into play in math achievement. And so you would expect to see these variables in a model. It's not a shocking model. So the fact that it has great significance has been borne out in the other research, other evidence. So we look at this entire model and we say 34.3% of that result can be explained by this model. That means that somewhere around 66% is other things. Maybe it's, did the kid eat breakfast that day? Maybe it's how anxiety ridden are they, or how chill can they be when they're taking the test. All kinds of things can come into play on that test. So we can explain a good chunk of it, 1/3 of it, we can say is contributed by these variables. We're never going to be able to explain everything. It's a pretty strong model, though, to say we can explain 1/3 of it. The last piece of this that we've talked about pretty extensively in the discussion groups that I want to make sure that everyone is clear on is just because not all of these variables are significant in the model in terms of how much they are contributing and their intercorrelation, they are contributing to one another and to the whole. And so we can't just take them out and explain it all and expect it all to be still the same explanation level. And there's a certain piece of this that we expect to see in the model based on the theory. And so just think about that logically. It makes sense to have both parents' education in there, even though they're not significant in terms of their intercorrelations. All right. So then the last piece is to say, what if we were applying this to an OPWL type test? And some of you guys had some really great examples in your discussion threads of ways that you could use multiple regression. Remember that the dependent variable we want to be a scale variable. So maybe this would be in thinking about Kirkpatrick's 4 levels of evaluation. Maybe our dependent variable would be a level 3 evaluation, so that we would look down the road and say, what level of performance are we likely to see when we have established performance improvement plans according to best practices. And so some of our variables might be that we have established a performance plan for our employees. That would be a nominal value. Yes, no, established. Then maybe we've got a midterm or an interim report on that performance improvement plan, and the manager rates the employees on a Likert type scale. How well are they performing relative to the goals? Is it very poorly or is it very well? And so that would be an ordinal type of variable. Then maybe we might have some kind of interim performance test. So 1 month out from some kind of training or development exercise, we have assessed the employee's performance, and we have a scale variable, and we array all of those in this relationship. We put all of these together and we say, okay, well, all 3 of these variables are contributing to a positive outcome on our performance measure. And hopefully it would be contributing significantly, which would mean that R value, that R square, would be greater than 0 significantly, and we would want to see that at 0.05. So hopefully that makes sense, and this is all coming together for you. always, let me know if for some reason you're still struggling with this, and we can definitely talk it out.